Have you ever really stopped to think about the sheer amount of data that's powering all the AI we see today? I mean, it's the engine behind so much innovation.
Absolutely. But the thing is, getting hold of all that real-world data, well, it's often incredibly messy, sometimes surprisingly hard to find, super expensive, or just tangled up in really serious privacy rules.
Right. But what if you could almost like design your own perfect data? Data tailored exactly to what you need.
That's exactly where we're heading today. We're doing a deep dive into synthetic data, artificially created information. It's carefully built to, statistically match real world data. But, and this is key, it doesn't have any of that actual personal sensitive stuff in it. Think of it like a digital copy of your data's patterns, but without the privacy risks.
Okay, so our goal today is to really get under the hood of synthetic data. What is it? Why is it suddenly becoming so vital for AI? What are the maybe surprising business benefits? And also really important, talk honestly about the challenges, the tricky parts in making and using it. It's definitely more than just a privacy fix.
Yeah, for sure. And to help us navigate this, we've pulled together insights from some really solid sources. We're looking at articles from folks like CIO, NVIDIA, AWS, TechTarget, research from IBM, mostly AI, and even official reports from the European Data Protection Supervisor and the Royal Society. So a pretty broad view.
Great. So let's start at the beginning. When we say synthetic data, what exactly are we talking about? The sources seem pretty clear. It's data made by computers.
Right, but made in a specific way. It reproduces the statistical features, the structure of the original data. It's artificial, yeah, born in a digital world, but it mirrors the real stuff mathematically. It captures the patterns, the relationships.
And the crucial bit is what it leaves out, isn't it? No sensitive private info that could point back to a real person.
Exactly. And that makes it totally different from, say, mock data, which is often just dummy text or numbers, placeholders really, with no real statistical meaning. And it's also different from data augmentation. That's where you take real data and just tweak it slightly, like you rotate an image or something to get more training examples. Synthetic data is built new from the ground up, designed to act like the original without being the original.
Okay, got it. And while it feels very cutting edge, the idea itself has been around for a while, hasn't it?
Oh, yeah, surprisingly long. Our sources trace it back to the 1940s, actually, to people like Stanislaw Ulam and John von Neumann using Monte Carlo simulations. Pretty foundational stuff. But the modern idea, especially for privacy, really kicked off with Donald Rubin's paper in 1993. He talked about creating these simulated data sets that looked statistically real but didn't reveal anything confidential. That was pretty groundbreaking for handling sensitive data back then.
And you can sort of draw a line from that to now with a huge explosion in AI, right? Like the ImageNet competition in 2012.
Absolutely. That moment, what some call the Big Bang of AI, really launched deep learning into the mainstream. And suddenly, everyone needed way more data to feed these incredibly powerful neural networks. The old ways just couldn't keep up.
Which leads us straight to the big question. Why the massive surge in synthetic data right now? You mentioned AI models needing huge amounts of data.
Immense amounts. And not just any data, high quality, carefully labeled data, but real world data is often, well, a pain. It's expensive to get, takes ages to collect and label, often has big gaps, can be really messy, and maybe the biggest hurdle comes with huge privacy and compliance issues. Think GDPR, HIPAA. Those regulations seriously limit how you can use personal info.
Yeah, those compliance hurdles are massive.
Totally. And Gartner's prediction really drives this home. They think that by 2030, most data used for AI will be synthetic. That's up from less than 5% in 2023. It's a huge shift. It suggests we're moving from synthetic data being like a niche thing to it being fundamental for AI development. How else can we keep fueling AI innovation ethically and efficiently?
It feels almost inevitable then. And generative AI is pouring fuel on that fire, isn't it? Making it easier, faster.
Exactly. Things like large language models are democratizing it. Suddenly, generating synthetic data isn't just for massive companies with huge data science teams. It's becoming faster, easier, more accessible. Smaller teams, even individuals, can start generating complex data sets now. It really speeds things up.
Okay, so let's get practical. Where does this actually create value for businesses? Our sources point to, what, 7 key areas? Let's start with the first one. Building AI that really gets your specific business.
Yeah, this is a really important one. The big AI vendors, they train these massive models on public data. They're powerful, sure, but they're generic. If you just use those off the shelf, you might not get much differentiation, and they might carry biases or inaccuracies that just don't fit your world. Synthetic data lets you fine-tune those big models or even build smaller custom ones that are laser-focused on your unique needs, your specific customers, your niche products. That's a real competitive advantage.
And we see companies doing this already, like Nextuple, the inventory management folks. Their CEO, Darpan Seth, mentioned they've used synthetic data for years to build custom AI for tricky decisions, like where to send big batches of inventory.
Right, and he specifically said that with generative AI now, things like creating the user stories, the test cases, even the test automations for these models, it's become blazing fast. It just streamlines everything.
It's a faster, more tailored AI with secondary, filling data gaps.
Exactly. Real data is almost never perfect. It's got holes. Maybe because customer behavior changes fast. Think about how Black Friday shopping suddenly shifted online. Or maybe because certain important events just don't happen very often.
Like accidents for self-driving car training.
Precisely. Or the example from Karen Panetta at Tufts University. She used synthetic data to generate videos of really rare but critical traffic accidents like vehicle rollovers. You need to train systems to handle these, but they hardly ever happen in real life, so you synthesize them. She also tried using it for facial recognition under tricky conditions, like wearing masks, showing how you can create those edge cases that real data often misses.
Makes sense. Okay, number 3 is probably the one most people think of. Privacy.
Yeah, protecting privacy while still getting value from data. This is huge in sectors like healthcare, finance, law, anywhere with strict regulations like GDPR or IPESI. Synthetic data lets them analyze trends, do research, train models, all without exposing sensitive personal info.
So a hospital could simulate patient data, maybe test new diagnostic tools, without ever using real patient records.
Exactly. They can create diverse, realistic scenarios, comply with the law, and build better tools or find new insights. Eric Lin from Dynamo AI also pointed out how you can use it to strip sensitive info from things like customer emails before using them for AI training. You unlock data that was previously just too risky to touch.
Okay, 4th point. Accelerating product development in R&D, especially when you're building something totally new.
Right. If it's brand new, there's no history. Where do you get the data to test it?
That Nextuple example comes up again here, doesn't it?
Yeah.
They use synthetic data for a new inventory app.
Yeah, they simulated things like how quickly inventory would be used up or huge demand spikes like around Thanksgiving. This let them test their app's logic before it went live without needing any real historical data. And it's not just software. Agustin Huerta from Globant highlighted how crucial it is for training robots in virtual worlds like NVIDIA Omniverse. And for autonomous driving, you really don't want to be crashing actual cars while you're still developing the system. Synthetic data gives you that safe sandbox.
A safe sandbox, I like that. Okay, 5th. Exploring new markets, where you also might lack data.
Absolutely. You can model how consumers might behave or how a product might perform in a region you're considering entering, even if you've never operated there before.
Like a bank simulating local spending habits in a new city.
Precisely. Anand Rao from Carnegie Mellon had a great example with a ride-sharing company. They used synthetic data to test over 200,000 scenarios across 10 different cities to fine-tune their launch strategy. They could adjust for things like how long customers in that specific city would tolerate waiting for a car. Super granular insights, all generated synthetically.
That's detailed. 6th point. Constructing digital twins. But not just for physical things.
Right, the idea is expanding. We're talking digital twins of software systems, business processes, even sort of people or customer groups.
So like creating synthetic customer profiles.
Yeah, Tom Edwards from UI talked about that. Creating synthetic profiles to understand buying habits, map out customer journeys, predict responses to marketing. It helps with demand forecasting, better targeting. And Nick Kramer from SSA & Company uses synthetic employee personas. They simulate project teams to figure out the best staffing mix based on skills, tools, desired speed, cost, revenue, margin. It's about modeling the whole operational ecosystem.
Okay, fascinating. And the 7th point. Preparing for agentic AI.
Yeah, AI agents, AI that can act autonomously are a big coming trend. But privacy is a massive roadblock for them. How do you train an agent that needs access to lots of potentially sensitive data?
So synthetic data provides the training ground again.
Exactly. It lets these agents learn by running through millions, literally millions of different scenarios in a safe, private, synthetic environment. You can make sure they can handle weird, unexpected situations without risking real data or real-world consequences. It's going to be vital for deploying these agents reliably.
Okay, so we've seen why the business value is clearly massive. Now let's dig into the how. How is this magic data actually made?
Well, it's not quite magic, but it is clever. Fundamentally, it involves using computational methods, simulations, to mimic the statistical patterns of the real data.
So what are the main ways?
One basic way is looking at the statistical distribution. You analyze your real data. Is it a bell curve, like a normal distribution? Is it exponential? Once you figure that out, you generate new data points that follow the same mathematical pattern. They look statistically similar.
Okay, that sounds fairly straightforward. What else?
Then you have model-based methods. Here, you actually train a machine learning model on the real data. The model learns the characteristics, the relationships, the complexities within that data. Then you use that trained model to generate brand new artificial data that has those same learned properties.
Right, the model becomes the data factory, essentially.
Kind of, yeah. And then you get to the really advanced stuff, the deep learning methods. You've probably heard of GAN, Generative Adversarial Networks.
The ones where two AIs fight each other.
That's the basic idea. You have a generator network creating the fake data and a discriminator network trying to spot if it's real or fake. They compete, constantly getting better, until the discriminator basically can't tell the difference anymore. GANs are amazing for creating really realistic stuff, especially images and video, but they can be tricky beasts to train well. Sometimes they get stuck generating the same thing over and over. That's called mode collapse.
Okay. What other deep learning approaches are there?
There are also VAEs, or variational autoencoders. They work a bit differently. They learn a sort of compressed code, a meaningful representation of the original data, and then use that code to generate new data with slight realistic variations. They're really good when you want synthetic data that's similar to the original, but with subtle changes. And of course, especially for text, you have transformer-based models like the kind behind GPT. They learn the deep structure and patterns in huge amounts of text data and can then generate new, coherent text based on a prompt. Shows how sophisticated generation has become.
And one really big advantage you mentioned earlier, the labeling.
Oh yeah, this is huge. Often, synthetic data comes out already labeled. Think about that. It just bypasses that incredibly slow, expensive, sometimes almost impossible job of having humans manually label massive data sets.
Which can take forever.
Exactly, because the machine created the data, it knows what it is, it knows the objects in the synthetic image or the categories in the synthetic text, it applies the labels automatically. That massively speeds up the whole process of getting data ready for AI training. It's a monumental benefit.
So while privacy gets the headlines, there's clearly a lot more going on. You mentioned addressing bias earlier.
Yes, and this is a really profound application. AI models, as we know, often inherit biases from the data they're trained on, historical biases related to gender, race, you name it, stuff baked into real-world data. What's powerful is that you can intentionally design synthetic data to counteract this. You can create fair synthetic data sets that represent the world maybe more like we want it to be, rather than just reflecting past inequalities. This can directly help reduce bias in the AI models trained on it.
So you're building fairness in from the start, rather than trying to fix bias models later.
Precisely. It offers a more unified, proactive way for an organization to tackle fairness across all its AI, instead of playing whack-a-mole trying to de-bias individual models after the fact, which can feel, a bit patchwork.
That makes a lot of sense. What about making models more robust? Data augmentation.
Yeah, this is one of the most successful use cases, really. Using synthetic data to expand your existing data sets, you add more examples, importantly examples that are sufficiently different to help the model learn better.
So it sees more variety.
Exactly. It helps the model generalize, perform better on data it's never seen before, and this is absolutely critical for handling those really rare edge cases.
Like the self-driving car example again. That weird scenario it might only encounter once in a blue moon.
Right. You can't wait for that to happen 1,000 times in real life. But you can generate it synthetically thousands, even millions of times. You build a much tougher, safer model that way.
And it's used for testing models, too. Finding flaws.
Definitely. Reducing vulnerability. IBM researchers, for instance, built a tool that could create fake quote tweets to see if they could fool stock prediction AIs that scan social media. And they showed they could actually manipulate the AI's decisions. That highlights a potential security risk.
And they also use it to find hidden biases.
Yeah, they built another tool to sniff out biases in large language models. Then it could generate counterfactual examples, like if the text said my boss is a man, it would generate my boss is a woman, and use these pairs to retrain the model to treat them equally, making it fairer.
Clever. And the last point here was about exploring what-if scenarios.
Right. Synthetic data lets you play around with hypotheticals. You can tweak the statistical distributions, apply different what-if conditions, and see what the likely outcomes might be, all without any real-world risk. It's incredibly valuable for strategic planning, forecasting, understanding cause and effect.
Okay, this all sounds incredibly powerful, but like any tech, there have to be downsides, challenges, right? What's the reality check here?
Absolutely. And the first, maybe the most critical point our sources stress is that synthetic data is not a magic bullet replacement for real data.
It's not one-to-one.
No. Especially when you need strong privacy guarantees, the synthetic data is necessarily a slightly distorted or maybe abstracted version of the real thing. That means if you only use synthetic data for building and testing your final AI, you're taking on extra risk. The best practice is almost always to evaluate and fine-tune your final model on some real-world data before you deploy it fully.
Okay, so it complements real data, doesn't totally replace it. That leads to quality control, I guess, and maybe trade-offs.
Exactly. Getting the synthetic data accurate and useful is obviously key, but there's often this tension. To make absolutely sure no one can link a synthetic data point back to a real person, you might have to sacrifice some level of detail or accuracy. There's a real trade-off between privacy and perfect fidelity.
And can it capture everything? What about really unusual things, outliers?
That can be a struggle. Perfectly mimicking all the weird complexities of the real world, especially those rare outliers or anomalies, is hard. The Royal Society report used the example of trying to include, say, a multi-billionaire's wealth in a synthetic dataset privately. It's tough because that extreme value is itself potentially identifying, but those outliers can be crucial for things like fraud detection.
Right. And you mentioned a misconception that it's not automatically private.
Yes, this is super important to hammer home. Just because data is synthetic doesn't mean it's inherently private. If it's not generated carefully using the right techniques, it can leak information about the original data.
So the privacy comes from how it's made.
Precisely. Strong privacy guarantees, like differential privacy, are a property of the algorithm used to generate the data, not the data set itself. Differential privacy gives you mathematical proof that an individual's data didn't overly influence the output, protecting against re-identification. So just looking at a synthetic data set can't rigorously prove it's private, although analysis can certainly find flaws if they exist.
Which implies this isn't easy to do well. It needs expertise.
Oh, definitely. Generating high-quality, truly private synthetic data, especially for complicated data sets with lots of variables, it requires serious technical skill. You need to understand advanced statistics, machine learning, the privacy techniques, specific rules of your data. It's definitely not a simple point-and-click process for every situation.
And that complexity can lead to confusion for people in the business using it.
Yeah, that happens. Because it's newer, some stakeholders might not fully get its value, or maybe they trust the results too much because it looks so clean and controlled. Clear communication about what it can do and what its limits are is absolutely vital for using it effectively.
And the Royal Society report had that really key finding the impossibility result. What was that again?
Right, that was a crucial insight. They basically showed that you can't always have everything. There isn't a computationally efficient algorithm that can guarantee strong privacy, like differential privacy, and perfectly preserve all the statistical relationships, like correlations between all pairs of features, for every single possible data set.
So no perfect universal method exists.
Pretty much. It means there's no one-size-fits-all approach to making private synthetic data. You have to design the generation process with your specific use case in mind. You need to decide which statistical properties are most important for your task and prioritize preserving those, accepting that you might not capture absolutely everything from the original data perfectly, especially if strong privacy is paramount. You have to make strategic choices.
And that leads to the final challenge, this tension between different goals, fairness, privacy, utility.
Exactly. They can sometimes pull in different directions. As we said, capturing outliers privately is hard because they're unique. Similarly, ensuring fairness for minority groups who might be underrepresented in the original data can be tricky while also maintaining strict privacy for those individuals. It's a complex balancing act requiring really careful design and trade-offs.
So we've covered a lot of ground today. We've gone from the origins of synthetic data right through to its, well, really transformative effects on AI development, privacy, even tackling bias. It's pretty clear this is a seriously powerful tool, evolving fast, and unlocking things that were just impossible or way too difficult before.
For the latest tech insights, visit em360tech.com.